Hi everyone, in class today we talked about molar mass of both elements and compounds. We talked about Avogadros number, which provides us with a definition of molar mass. We'll talk about that in a moment. Avogadros number is a number kind of like a couple is 2, a dozen is 12, a score is 20. Avogadros number is just another number like those. And we also talked about the molar equation, which is this equation here. Little n equals lowercase m over capital M, the molar equation, where n is the number of moles of a thing, m is the mass of the thing in grams, and capital M is the molar mass in grams per mole. Right, let's get right into it. When we start with molar mass, we're asking the question, how much does 1 mole of a substance weigh? Now there's an analogy for this. We might say, how much does a dozen eggs weigh? Well, if you go to get a packet of eggs, you might see that there's 60 gram eggs individually on average. So 60 grams times 12 is 720 grams. So when we say, what's the molar mass? We're not asking how much does a dozen weigh. We're asking how much does a mole weigh? How much does an Avogadros number weigh? Not a couple. A couple would be 2. A dozen would be 12. A score would be 20. We're asking for an Avogadros numbers value, so a mole of these materials. If we want to know the molar mass of something, we can look at our periodic table. In our periodic table, the large number at the bottom of each box is the molar mass for that element. It's the grams per mole of that element. So when we look at carbon, the molar mass of carbon is 12.01 grams per mole. If we look at oxygen, the molar mass of oxygen is 16 grams per mole. That's 16 grams if you get together 1 entire mole's worth of oxygen. That's 12.01 grams if you get together 1 entire mole's worth of carbon. We can also ask the question, what is the molar mass of a compound? Carbon dioxide is a compound. There's a molecule called the carbon dioxide molecule. It's CO2. So if we ask the question, what is the molar mass of a compound like carbon dioxide, CO2? Well, we're asking how much does a mole's worth of these particles weigh in grams? This is 1 particle. It's got 3 atoms in it. It's got 2 elements in it, but it's 1 particle. 3 atoms, 2 elements, 1 particle. If we had Avogadro's number of these, how much would it weigh in grams? We use molar mass to figure this out. We take the values from our periodic table. The molar mass of carbon, 12.01 grams per mole. The molar mass of oxygen is 16 grams per mole, and we figure it out. So the molar mass of carbon dioxide is going to be the combined molar masses of 1 mole of carbon and 2 moles of oxygen. How do I know it's 2 moles of oxygen? Because we've got 2 oxygen atoms with every 1 of our carbon dioxide molecules. So 1 times the molar mass of carbon plus 2 times the molar mass of oxygen. And so we've got the molar mass of this compound, carbon dioxide, is 1 times that times 2 times plus 2 times that. And so the molar mass of this compound is 44.01 grams per mole. Magnesium hydroxide is another compound. It's an ionic compound. The smallest unit of the magnesium hydroxide salt is going to be magnesium and then 2 hydroxide ions, 2 of these. If we want to know the molar mass of magnesium hydroxide, we go to our periodic table and we get the molar masses of each of the elements, and then we multiply them out to find the molar mass of magnesium hydroxide. So when we try to figure out the molar mass of magnesium hydroxide, we've got the molar mass of magnesium plus 2 times the molar mass of oxygen plus 2 times the molar mass of hydrogen. How do we know that we've got these 2's here? We've got 2 as a subscript outside the brackets in the molecule. And so we see the molar mass of magnesium hydroxide ends up being 58.326 grams per mole. So as we've said, Avogadro's number is 6.022 by 10 to the 23 things, particles. This is an example of scientific notation. 6.022 times 10 to the 23. That means we take the decimal point and we move it this way, 23 spaces. 1 mole of anything is this number of that thing. 2 moles is 2 lots of that. 3 moles is 3 lots of that. Half a mole is half of that. So if I've got a quarter of a mole of hydrogen gas, I might ask the question, how many hydrogen gas particles or molecules do I have? So I've got 0.25 moles. How many particles of hydrogen gas do I have? 0.25 multiplied by Avogadros number, 0.25 multiplied by that, and we get 1.5055 by 10 to the 23 molecules. So this is how many hydrogen molecules are in a mole of hydrogen gas. That many. What is that? 1,000, million, billion, trillion, quadrillion. Too hard. I don't know the numbers. I much prefer scientific notation. So we figured out that 0.25 moles of hydrogen gas gives us 1.5055 by 10 to the 23 molecules of hydrogen gas. But how many hydrogen atoms are there? 3.011 by 10 to the 23 hydrogen atoms. 1.5055 by 10 to the 23 hydrogen molecules. Here's another question. Say we've got 0.27 mole of acetic acid. Well, how many molecules of acetic acid do we really have? This is acetic acid, CH3COOH. Ethanoic acid, acetic acid. We've got 0.27 moles. Right. How many particles of this do we have? Well, we have 0.27 multiplied by Avogadros number. 0.27 multiplied by this value, which gives us 1.62594 by 10 to the 23 molecules. So we've got this many molecules of acetic acid. How many oxygen atoms are present in this system? Well, in every single one of our molecules of acetic acid, we've got 1, 2 oxygen atoms. So how many oxygen atoms have we got in this many molecules? This many of those. It's 2 times that number. 3.25188 by 10 to the 23 atoms of oxygen in 0.27 moles of acetic acid. The molar equation allows us to bring it all together. We've got N equals lowercase m over capital M. What are we looking at here? This is the number of moles of your substance, of the thing that you're interested in. And the units for that is MOL, lowercase MOL. This is the mass of the substance that you have in hand, what you've actually got. And the units for mass of our substance is in grams. This is the molar mass of our material. We get this value from the periodic table. If it's a compound, we have to use the formula of the compound and the periodic table to find the molar mass. The units for molar mass are grams per mole. I can use the molar equation to figure out how many moles are present in 500 milligrams of salt. How many moles of salt do I have? Well, first of all, I'll go to my periodic table. Salt is an ionic compound with the formula NaCl. The molar mass of sodium is 22.99 grams per mole. The molar mass of chlorine is going to be 35.45 grams per mole. So I want to know the number of moles in 500 milligrams of salt. So salt is sodium chloride, NaCl. I can use my periodic table to find the molar mass of sodium, that's 22.99 grams per mole. I can use my periodic table to find the molar mass of chloride, or chlorine, that's 35.45 grams per mole. The molar mass of the sodium chloride ionic molecule, or the smallest unit of that ionic salt, is 22.99 plus 35.45, which equals 58.44 grams per mole. Now I can use my molar equation to figure out the number of moles present in 500 milligrams of salt. So I've got my molar equation, N equals little m over big M, and I know that the number of moles is going to be something divided by 58.44, but that's down there. But what do I have to put in this red box? I'm told that the mass of my salt is 500 milligrams. Well, 500 millimeters is equal to half a meter. So I'm going to guess that 500 milligrams are going to be equal to half a gram, 0.5 grams. So 500 milligrams of salt is going to give us 8.556 by 10 to the negative 3 moles. I rounded that up to the 6. Okay, I hope this was helpful.